So there are actually three ways that heat flows. Now remember, the flow of heat is actually the flow of energy, specifically thermal energy. So we know from thermodynamics that heat flows from objects with higher thermal energy, or heat, to objects with lower thermal energy. So thermal energy is transferred in these three ways depending on the medium that it's flowing through. And of course, those three ways are called radiation, conduction, and convection. So, radiation first. So, what's cool about radiation is it actually carries heat through empty space. So all objects warmer than absolute zero give off radiation as a form of light. But if an object's too cool to glow in the visible spectrum, it'll be bright in the infrared spectrum. So that's why people are bright in infrared cameras. A warm object gives off light waves called infrared waves, which move outward until they collide with another object. When they collide, their thermal energy is transferred to that object, and that object feels it, if it can feel, as heat. So that's why I've always been fascinated with radiation because, conduction, convection, they make sense as in, you can kind of sense it, the energy transferring from one thing to another. But the idea that heat can actually travel, through empty space without a sort of obvious medium is that's always just really fascinated me. But then that does lead us to the next, which is conduction. And conduction always makes a little bit more sense readily because it's how you carry heat from molecule to molecule. So heat energy causes a molecule to vibrate. A lot of us are familiar with that concept. Well, this motion is passed on to other molecules that it touches. You can kind of almost imagine like a molecule vibrating and moving. And as it's vibrating, what is it doing? It's bumping into the other molecules around it. And as it bumps, it transfers some of that energy to the one that it bumps. And then the one that it bumped starts moving around and it starts bumping other ones. And that transfer of energy is heat traveling from molecule to molecule. So these different materials, they conduct heat better, or worse. So gases and liquids are not very good conductors. Wood's actually a terrible conductor. That's why you often have, wood handles on older pots and pans and stuff like that, is because metal is a great conductor. So those molecules are bouncing around, hitting each other. They're very dense and they're heating up really fast. Then when they run into the molecules of the wood, it virtually stops. It's a terrible conductor. Um, that's why we call these insulators. They insulate against this molecule to molecule vibrating process. So if you don't want the heat to transfer somewhere, you use an insulator to stop that process in its tracks, and then you can grab that object, or then that heat doesn't escape, or something like that. Now, third is something called convection. And of course, here at Certek, we use convection a lot to transfer heat. So we're often heating water, because convection refers to heat as it travels through liquids and gases. Now, of course, both gases and liquids are fluids, and fluids become less dense when they're heated, so they rise, right? So whereas cooler molecules, they'll sink. Now this makes sense if you go back to the idea of these vibrating molecules. So as they're vibrating, as they're moving, you can almost sense that they're getting more space between each other. I mean, as they're running into each other in less space, of course, and then more space as they're moving. So they're vibrating, but they're creating less space around each other from one molecule to the molecule. So they're less dense, they're less compact, which is making them lighter and lighter. So the ones that aren't moving, the cooler molecules, they're still pretty dense. They're sinking down. These lighter ones are moving up. So then, of course, this this kind of creates this almost perpetual motion of these lighter, less dense liquid moving up, the colder ones taking their place down at the bottom, getting heated, as you would with one of our applications, getting heated, then it would rise. Meanwhile, those ones that already rose are warm, but they're cooling down, they're sinking down. You can kind of see this circular movement. They call those convection currents. And of course, these currents aren't obviously something that we came up with. The Earth naturally does this. Our weather patterns, our oceans, people that study beneath the Earth, magma in the core, they all work with these convection currents, or this heating and cooling of liquids and fluids to create the different currents and weather patterns that we take for granted. So, for instance, here at Certek, we have a product we call a hot pod. A hot pod hooks up to a Kodiak. Hot pod is really, I describe it as a trash can with a hole all the way down the center. It's about trash can size, maybe 4 or 5 feet tall, but on the inside it's got a hole and it's got a ring of copper pipe going all the way through, all the way down it. So that copper pipe, we run our warm glycol through it. And so it's heating up. And so there's a water column in between, in the middle of this hot pod. And that's going to heat up because you're transferring that heat from the copper pipe into the liquid that it's in, water. And that's going to heat up, become less dense. It's going to float up and going to be replaced by colder water through the bottom. And then that colder water will be heated up and it's going to rise up and it will be replaced. And so as you're doing this through this whole body of water, and often we're heating, things that are 30, 40, 50,000 barrels worth of water at a time. Imagine these sea rings, they're like above ground swimming pools. But over time, you're heating this whole body of water. You're not aiming to get it hot, right? This isn't going to get it hot, but this is going to keep the water circulating and keep the water heating so that it doesn't freeze. Because our objective, more often than not, with this application is freeze prevention. And so we're using convection, we're using specialized equipment designed to create convection within this body of water to keep it from freezing.